In this video, we're going to take a look at an overview of object relational mapping. First of all, what is object relational mapping? It's a technology used to easily map Java objects to a relational database. And why do we need this mapping? Well, relational databases typically exist and can support many different programs. Java is an object-oriented language. Not all programming languages are object-oriented, so we can't assume that everything was built for ease of use with Java. Many times when we're working on software, we're working on integration, taking data from multiple areas and integrating it together to create valuable information out of it. So given that the object-oriented paradigm and the relational database paradigm are slightly different, there's what Hibernate calls the object-relational impedance mismatch. We'll take a look at that in greater detail in a future slide. Now, what are alternatives to using object-relational mapping? Well, probably the most common alternative is what we're going to call JDBC, Java Database Connectivity. With Java Database Connectivity, we have what's called a driver, and the driver is software that allows us to connect to the database. And then we'll have SQL statements inside our code somewhere, preferably in the DAO layer. And that's why in this course, it's very important that we stratify our applications into a user interface, business logic, and persistence layer, so that we keep those SQL statements down in the persistence layer. We do not want to pollute the user interface layer with database-specific SQL statements. Think about what a J2EE app really is. It's an app that can have many faces. Think about the ways that you interact with a retailer. We traditionally think the point of sale, but you also have their website and perhaps their mobile app, maybe self-checkout. So all of these are different user interfaces that are going to lay on top of the same or similar business logic and the same or similar persistence logic. That's why it's important to stratify these things into layers. So with JDBC, we would have what's called a driver, and then we were in charge of writing our own SQL statements, which means that developers were oftentimes writing their own SQL statements, which maybe isn't the best idea, maybe it is a good idea. So we still use JDBC under the covers with object relational mapping, but we don't have to worry as much about simple SQL statements that would frankly just be a whole lot of syntax and potential syntax errors that we would have to deal with. One potential issue with putting SQL statements directly in code is that you don't know whether it works until runtime. So SQL statements tend to be a runtime error, and we don't like those. Runtime errors, if you remember our previous video on errors, runtime errors are things that will cause a program to crash when it's running. So with Hibernate, it's a little bit cleaner because in the simplest case, we're just mapping a Java object from our DTO package to a table in the database. For a simple query, that's all we have to do. Another alternative is something that we're seeing a lot more now is a NoSQL database. This is something where we're essentially just storing documents. Those documents can be things like JSON data, for instance. Now, Hibernate is probably the most common object relational mapping framework. It is a Red Hat product. It is an open source product, so it doesn't cost us any money. There are alternatives as well. There's something called iBatis, which is frequently used for mapping objects in a DTO layer to a database, and we can write queries in iBatis as well. iBatis kind of got mothballed, to be honest with you, and then a fork came called myBatis, which contains a lot of improvements. Just as the software gets older and gets improved on. So if you were looking at iBatis versus myBatis at this point, I think it'd be a pretty strong argument to use myBatis. But nonetheless, Hibernate is very common, and that's why I've chosen to use it for this course, because a lot of people either know Hibernate or a lot of employers are looking for people who know Hibernate. Okay, so the ORM impedance mismatch. Granularity, this is what's defined by Hibernate.org. This is why we need to map from objects to a relational database. Granularity means that we could have more classes than we have tables in the database. So we have to figure out how to map these. Subtypes is an especially interesting one. Think about a class and its subclasses. So we could have car, and under that we could have Corolla, Cavalier, Neon, whatever you wish to say. We would save all of these in one table called maybe car. Okay, but how do we know if something is a Cavalier, Corolla, or a Neon? And why do we even care? Well, saving the object is one thing. But getting the object back is another thing that we also have to carefully consider. If I persist the object and then later on, maybe a few days later, a user logs back in, I want to pull that object back out of the database. How do I know if it's a Cavalier, Neon, or Corolla? Well, Hibernate gives us an option called a discriminator column, which is where we basically have a column that says, okay, I'm in the car table, but specifically, this is the subtype of car that I am. Identity. So identity means that in Java, we oftentimes look at the object under the covers. So we have to think about what identity is versus a quality. You know the trick about strings. You can use double equal to compare primitive data types, but if you want to compare strings, we typically use equals or equals ignore case as a method. The reason why we use the method is we're simply saying, do these two string objects contain the same data? Double equals means, are these two string objects the same object? That's a different identity. It's a different comparison. Subtle, but different. The same object means they're the same thing. They occupy the same space in memory. But we could have two different objects that just happen to have the same values inside. And that's what that dot equals and dot equals ignore case is telling us. Are these two different objects, two different places in memory, and they just happen to have the same contents? That's why there's that confusing difference between the two. Okay. Then we have associations. In relational databases, we tend to think one-to-one, one-to-many, many-to-many. And we think about foreign keys and things with that. With an object model, we tend to have a direct relation from one object to another. So we might have a car, and that car might have a collection. The collection could be something like individual models of that car that are sitting around, or a number of doors, something like that. Additionally, we have data navigation. In Java, a lot of times we will use what's called kind of a graph syntax, where we'll say car.getTransmission.get number of gears. Okay, so we're using a .get to navigate from car all the way down to the number of gears. In a database, it's a slightly different consideration because a lot of times we're using join statements. So this is why we need object relational mapping. One good thing about object relational mapping, I mentioned a bit earlier, is that we don't need SQL. We're really just mapping a DTO to a table. So for a simple select, insert statement, anything like that, we don't need SQL. Hibernate can do more than just mapping DTOs to tables. It has options to create Java classes from the database schema and create the database schema from Java classes. So it can go either way in theory. But except for simple programs, we really want to consider and optimize these two things separately, our object-oriented design and our relational database. They have different needs and can be tuned separately. More importantly, a lot of times they're not built at the same time. Many times we're integrating an existing database with a new Java program or a new database with an existing Java program. So that's where the object relational mapping comes in handy. What do we need to do to make this happen? We need a POM entry, and I have all this on our virtual machine. We're going to look at it in an example in just a moment. We need a Hibernate configuration file, hibernate.cfg.xml. Now, I know this is one more configuration file. We've already looked at faces config, which configures our JSF implementation. We have looked at application context, which configures Spring. We've looked at web.xml, which configures our website. So this is one more configuration file. This one is specific to Hibernate, and we're going to put this in our source folder. After that, we need something called Hibernate util.java, which is essentially a static class that has a lot of information to help us bootstrap the Hibernate process. By that I mean it just sets things up. We'll put this in our DAO package. After that, for each DTO that we're mapping, we're going to have an hbm.xml file. This is where we specify the properties of the mapping. In other words, we say this getter setter method, it maps to this column in the database. We can say things like our discriminator column. We can say things like that. The name of the file will typically be the entity name.hbm.xml. That extension hbm.xml is fairly static, but the entity name is going to be dependent on which entity we're mapping. In other words, a plant would be plant.hbm.xml. A specimen would be specimen.hbm.xml. So on and so forth. So there will be several of these files, and they will be included at some point in our master Hibernate config XML file. Okay, the entity hbm.xml will typically have this type of syntax: a Hibernate mapping root element, and then we'll have a property name equals type. And or property name and property type, those are actually two different attributes there. So the name would be the attribute name within our class. In other words, genus is the attribute name. It has method getGenus and setGenus, but just that name genus is the name that we're going to have here. And then type says what is the data type of that variable. So for genus, it would be string. For our global unique identifier, it would be a number. Okay. Now we're going to have nested inside of this tag a column name equals tag, and that says this property matches to this column. Additionally, for an identity primary key, we're going to have generator class equals identity. So that's what we have. That's a quick summary, entry level of Hibernate and ORM. In the next video, we're going to actually implement some of this. And if you need a little bit of a refresher as well, I'll recommend going back to a video that I've posted on our learning module. This is an entity relationship diagram that we created earlier in the semester. Right now we're just thinking about the plants table, but as we go on the semester, we'll add a specimens table with perhaps a one-to-many mapping, maybe a contributor, photo, and collection table. And remember what the crow's feet mean here. On the one side, we have the one. And on the, where you see the kind of the three legs popping out, that means we have a many. So a plant is the scientific definition of a plant, where there can be many specimens, which are the things that you touch from a plant. In other words, a plant you can physically see, a plant you can physically touch. A contributor can contribute many specimens. A specimen might have many photos, but those photos all relate to one specimen. Specimens might belong to a collection. So that's a bit of a previous video I've linked. I recommend going back to if you need a bit of a refresher. And then after that, we're going to take a look at actually implementing Hibernate. I look forward to seeing you then.